Welcome to this demo of how to bring your LLM from Google Cloud to Salesforce Data Cloud using Data Cloud's LLM Open Connector. In this video, we'll walk through the end-to-end process of using Google Cloud's Vertex AI to deploy a fine-tuned Gemini model or any other model you prefer, and then connect it to Salesforce Data Cloud via the LLM Open Connector. Here's our high-level flow. We deploy a fine-tuned Gemini model on Vertex AI. We then create and store an API key in Secret Manager. We set up a Cloud Run function to serve as a middleware, handling authentication and payload transformations. We then configure Salesforce Data Cloud's LLM Open Connector in Data Cloud Einstein Studio to call our model endpoint. This approach allows chat completions or other LLM use cases within Salesforce using a secure, scalable Google Cloud backend. So let's start with the Google Cloud console. We will first navigate to the Vertex AI model garden. So we go to Vertex AI and we head on over to model garden. As you can see here, there are several large language models available right here from within model garden. There are also several models available that can be fine-tuned. For this demo, we're using a fine-tunable Gemini 1.0 Pro, but you can choose any foundation model from Model Garden for this use case. Now, supervised fine-tuning involves training a large AI model on specific examples so that it works better for your particular task. Now, this approach is especially useful when you have clear tasks with labeled examples, such as handling chat conversations. Now, if you head on over to just fine-tune this model, you can see this interface, which is allowing you to select a base model. You can also select the region. You can establish the number of training rounds, which is represented by epochs. You can add a learning rate multiplier or adapter size. Now, typically, fine-tuning can take some time, but let me show you how you would structure your file if you plan to fine-tune a model. It needs to be prepared in a JSON-L format, where each line is a separate example of a conversation. Now, each message in this training data it's an array that has multiple parts. One part indicates whether the role, whether this is a user or the AI model. Then the other part contains an array which contains the actual text of the message. For example, the user's question is in one object and the model's response is in other. In a nutshell, each line is a separate example, is a contained example of a conversation. Now, once your training data is ready, you can go ahead and create your training jobs from within Vertex AI itself. Now, for this specific demo, we have already deployed a fine-tuned model here, fine-tuned Gemini Flash Pro. What we need to note from here is that we need to note the model's ID, the model's name. Also, you need to remember the project ID in Google Cloud. So Data Cloud LLM Open Connector is our project ID. So just to recap, we've fine-tuned the model with the training data in the JSON-L format, and then we have deployed the model. And once we have deployed this model, we have noted down the name of the model, the ID, as well as the project ID. That's all we need for the next step. Now, before we head on over to establish our Cloud Run function, which will serve as a middleware, we need to establish a secure way for Salesforce to authenticate when it is calling our model endpoint. So for this, we'll be using the Google Cloud's Secret Manager. We've already configured a secret here called LLM Connector API Key. This is where we are storing the API key that we have generated in a safe and secure manner. The other piece that we are ensuring is that the service account, as you can see, we have a common service account, which has at least the secret accessor and secret manager, version manager roles assigned within Google Cloud. And this is the same service account that we will use for the Cloud Run function as well. These roles may evolve. The best thing to do here is to consult Google Cloud documentation so that you bake this function with the latest and greatest as is needed by the Google Cloud platform. Few things to note here. We have set the expiration as never, just for convenience, but you can set up a key rotation process using Cloud Run functions when you choose to extend this example. Now let's go to the Cloud Run function. Cloud Run functions are event-driven serverless functions, and in our use case, this function is our middleware. It'll retrieve the API key from the secret manager that we have stored here. It'll also validate the requests that are coming in from Salesforce Data Cloud. It'll convert that incoming payload to the Vertex AI compatible format, and then it'll send the request to our Gemini model endpoint and return the response in Data Cloud's LLM open connector format. There's a lot happening here, so let me take you through the function itself. We'll examine the source files of the function that we have created in a step-by-step manner. From the top, we are importing libraries to interact with Secret Manager and make requests to Vertex AI, handling the OAuth 2.0 and log events. We also define constants like the project ID, the location, and the endpoint ID, the critical piece of metadata that we have collected during our configuration. The get secret API key function uses the secret manager client to fetch the latest version of our secret named LLM connector API key, and this ensures we never hard-code sensitive information directly into this function. Now, validate API key, it reads the API key header from the incoming request from Salesforce and then compares it with what's in the secret manager. And if they match, the request is authorized, otherwise it is rejected. Get access token uses the default service account credentials provided by Cloud Run, and if the credentials are valid, it refreshes them. This token is needed in order to call Vertex AI's secured endpoints. From there on out, the function is triggered whenever Salesforce sends a request to our Cloud Run URL. And let's break down what it does step by step. It starts by handling pre-flight requests or allowing cross-origin calls. It then validates whether the path has the chat completions suffix, which aligns with the OpenAI-like endpoint, which is required by the LLM open connector framework. We're going to see that here shortly. It also only allows post requests for this endpoint. Any other method returns an error. And then we also call our validate API key function, which we just examined. We ensure that the JSON body has a messages field following the OpenAI-like schema. And then we run that payload transformation for Vertex AI in the generate content endpoint format. And we also set the generation parameters like max tokens and temperature. And then we get an OAuth token via the get access token function that we saw. And we send a post request to the Vertex AI endpoint, which uses the request library. And if the response is successful, we parse out the generated text and usage metadata and return it to Salesforce in an OpenAI-like format. This ensures the LLM open connector can process it correctly. Now, all of this is here in the function. There are a few things that we need to note. This is part of a cookbook that accompanies this video. A few things you need to note over here. First is we need to know this URL of the Cloud Run function. The other piece is that this needs to be set up as allow unauthenticated invocations, because this is how the OpenLLM connector can access it. The security parameters, that is fetching the secret, validating it, refreshing the token, all of this is baked into this function itself. We've seen this in the source file. It returns an error if any of the criteria does not meet. So this is actually managing the security piece. The other piece to remember, I'm just going to hit edit here. I'm not actually going to edit it. But another piece that you need to see here is the environment setup that we have done for the function. You can evaluate that. And if you go over to security, you can see that the service account here is the connector cloud run function service account. If you recall, this was the same service account that we have used for the secret key as well. And here you need to assign some specific roles. This service account needs to be able to use Vertex AI. There are a host of roles that you need to apply to the service account of this function so that the function runs in a smooth manner. If this changes at the time of writing, the best source to go and validate any of this is directly in the Google Cloud documentation. So we've noted down a few things here. We've noted down we have the API key. We also know what is the name of this fine-tuned model, which we got from the Model Garden endpoints that we examined over here. So with all of this information, let's head on over to Salesforce Data Cloud. In Salesforce Data Cloud, let's go to Einstein Studio. This is where we will head on over to model library, which is where we can see all the different models that we have. But we now actually want to add a foundation model. That is what we're going to do. This is our foundation model. As you can see, BYO LLM gives you actually a lot of models out of the box. But what we are going to do is we're going to connect it to our LLM. So let's go over. Again, the endpoint, I like to name it exactly what it has been named in Google Cloud. This ensures that we maintain parity. Hold on, let me just paste this. We also need to append the URL of the Cloud Run function with chat completions suffix. Remember, our Cloud Run function is looking for a URL in this format. We also paste the auth key over here. This is a one-time configuration. Remember, if you rotate the key, this needs to be updated, as is the case for any configuration that you would do to bring in an external model. And then let's also give it a provider's model name, and let's hit connect. Now, in the next step, what we are going to do is create a configuration specifically for the chat completion capability. This will help us invoke this model from within Agentforce and Prompt Builder and allow us to apply this model to our Agentforce use cases within this org. Now, there are a few things to note here. We are going to select the foundation model that we have just deployed. We're going to select the chat completions capability. And the next thing we will do is we will test this with a prompt. Now, I have written down a prompt which is quite specific to my training data here. We're just trying to see if the model is actually being used. And we can set up some parameters here around the temperature as to the degree of usage of the training data and the LLM data over here. Let's test this by generating a response. It also gives you debugging capabilities within the same platform, which I find extremely useful. As you can see, we're getting a fairly detailed response. Actually, this is pretty good. I'm happy with this, and I'm going to save this configuration just as is. Again, the model name I'm going to give here is Fine-Tune Gemini Flash Pro. This helps maintain a parity in our implementation between the two platforms. All right, congratulations. You've successfully integrated Salesforce Data Cloud with a Gemini model on Vertex AI using the LLM Open Connector. What you can do next is you can try different foundation models here from within Vertex AI Model Garden. You can try different models. You could even, it need not always fine-tune a model. You can try out an existing model as well. You can alternatively also go into the security function and try to extend this function to suit your enterprise use case. You could also extend this Cloud Run function itself. If you are looking for certain other sophisticated middleware capabilities, you can make those changes from within the Cloud Run function. And you can also explore advanced prompt design and use cases within Salesforce. All of this is in a seamless manner between the two platforms. Thank you so much for watching, and happy building.